So this is the review video for the Chapter 5 quiz review homework. So number 1 gives you a point, -3.7, and wants you to write the equation of the line through the following gradients. Remember, gradients is the same thing as slope. And we're given a point and slope. So the best form of the line to use would be point-slope form. And then if you need to switch it into a different form, you can always switch it from there. So part A gives us a slope of 2, or a gradient of 2. So I plugged in -3 for x1, 7 for y1, and 2 for m. So you get y minus 7 is equal to 2 times x minus -3, or an x plus 3. It doesn't tell us to put the line in any specific form, so this is a perfectly correct answer. You can just leave your line in that form. So part B, the only thing that changed is your gradient is now a -5. So the only difference between the answer in part A and the answer in part B is your 2 became a -5. Again, it didn't ask for your line in any specific form, so you could have left it here. I wanted to show switching it into slope-intercept form, y equals mx plus c. So I distributed the -5 into the parentheses, so you get -5x minus 15, and then added 7 to both sides, so y equals -5x minus 8. So these are both correct answers in this case, because they don't tell you what form of the line to write it in. So this one, they give us a gradient of -3/4, but they want us to write the answer in standard form, ax plus by plus c is equal to 0. So I started out in point-slope form. Y minus 7 is equal to -3/4 x plus 3. What you should notice for all A, B, and C, the only thing that changed is the slope, because the point stayed the same. So here your slope was 2, here your slope was -5, here your slope was -3/4. That's the only thing that changed. And then I wanted to clear out this fraction, so I multiplied everything by 4. So you get 4y minus 28 is equal to -3 times the quantity x plus 3. Then I distributed this -3, so you get 4y minus 28 equals -3x minus 9, and then added 3x and 9 to both sides to get this side equal to 0, and so you end up with 3x plus 4y minus 19 is equal to 0. And so that is your final answer, and that is the only acceptable answer because they specified what form to write your answer in. Number 2 gives you a graph with 4 lines, A, B, C, and D, and wants you to find the equation of each of those 4 lines in slope-intercept form, y equals mx plus c. So for each of these, we need to find the slope and the y-intercept to be able to write the equation of the line. So to find the slope on all of these, I did slope triangles. So for line A here, I found 2 points that intersected at nice integers and saw that we go up 3 and to the right 1, so our slope is 3. And we had a y-intercept of positive 8. So we have y equals 3x plus 8. For line B, we go up 3 and over 2, so we have a slope of 3/2, and we go through the origin, so a y-intercept of 0. So you get y equals 3/2 x plus 0, or just y equals 3/2 x. For C, we go down 5 and to the right 1, so we have a slope of -5, and a y-intercept of positive 6, so y equals -5x plus 6. And then for line D, you go up 1 and to the right 2, so you have a slope of 1/2 and a y-intercept of -7, so you get y equals 1/2 x minus 7. Number 3 gives us 2 points, -1, -8, and 1, 2. Part A wants us to find the gradient, and then part B wants us to find the equation of the line that connects those 2 points in slope-intercept form. So for part A, I did slope formula, which is your change in y over change in x, or y2 minus y1 over x2 minus x1. It doesn't matter which point you pick to go first, as long as the same y coordinate and the same x coordinate go first. So I did 2 minus -8 over 1 minus a -1, and you end up with 10 over 2, which is 5. Or if you had done -8 minus 2 over -1 minus 1, you get -10 over -2, which is also 5. So either way, you end up with the same slope. For part B, I have a point and a slope. So I started out in point-slope form, y minus y1 is equal to mx minus x1. I first plugged in point C, so you get y minus a -8 is equal to 5 times x minus a -1. Distribute this 5, you get y plus 8 equals 5x plus 5, and subtract 8 from both sides, you get y equals 5x minus 3. You could have also plugged in point D instead and got y minus 2 is equal to 5x minus 1. Distribute the 5, y minus 2 equals 5x minus 5, add 2 to both sides, you end up with the same solution. So it doesn't matter which point you pick, you end up with the same answer. So both of these would be correct. So number 4 gives you a line 2y plus 3x is equal to 6, and they want us to graph that line, find an equation of a line perpendicular through a specific point, and find the equation of a line parallel through a specific point. There's a couple ways you could graph this. One way you could graph this, because this is in standard form, is you could use intercepts. X-intercept, set y equal to 0 and solve for x. Y-intercept, set x equals 0 and solve for y. That would have been pretty easy and would have given you a nice good graph. However, because I knew that I was going to have to find the slope to be able to find perpendicular and parallel lines in part B and C, I decided just to solve for y and put it into slope-intercept form. So I subtracted 3x from both sides and then divided by 2, so you end up with y equals negative 3 halves x plus 3. So I know my gradient is negative 3 halves, and my y-intercept is 3. So I graph my y-intercept at positive 3, and then down 3 and over 2, so here's our line of L1. For part B, they wanted us to find a line that is perpendicular to L1. So remember, perpendicular lines have opposite reciprocal slopes. So the slope perpendicular, that's what this little symbol means, is 2 over 3. So flip it over and change the sign, so 2/3. And then using point slope form with the point negative 3, 0, y minus 0 is equal to 2/3 x minus a negative 3, which you could simplify to y equals 2/3 x plus 3. They don't tell us to put the line in any specific form, so that's a perfectly acceptable answer. Part C, they want a line parallel, which means same slope. So if my slope here was negative 3 halves, then this is also going to be negative 3 halves. This little symbol here means parallel. So then plugging in the point 4, negative 7, I have 4 minus a negative 7 equals y minus a negative 7 is equal to negative 3 halves x minus 4. You could have written this as y plus 7 as well. Number 5 gives us a line 4x plus 5y minus 20 equals 0, asks us some questions about it, and then gives us a second line 20y minus 15x minus 18 equals 0, and then asks some more questions. So part A, again, you could have graphed this using intercepts. I knew that I was going to need a slope later on, so I put it into slope-intercept form. Y equals negative 4/5 x plus 4, so y-intercept of 4, slope of down 4 over 5, so here's our line. So part B, for number 1, we wanted a slope parallel, which would be the same slope, negative 4/5, and a general equation of any line parallel to that. So y equals negative 4/5 x plus c. C can be anything. Anything of this form will be parallel to this line. Number 2, we wanted the same thing but perpendicular, so our perpendicular slope would be 5/4. So we have y equals 5/4 x plus c. Again, c can be anything. Anything of this form will be perpendicular to this line. Part C, we have 20y minus 15x minus 18 equals 0. Again, I put it into slope-intercept form. This one did not have the nicest y-intercept, but you get y equals 3/4 x plus 9 over 10, and that's what this looks like here. And then part D, we want to find the point of intersection of the two lines. You could have set these two that were set equal to y equal to each other, substitution method. I did elimination method, so I multiplied this equation 4x plus 5y minus 20 equals 0 by negative 4 and added the two together to eliminate my y's. So you end up with negative 3x plus 62 equals 0, so x equals 2. Negative 31x plus 62 equals 0, so x equals 2. I substitute that into that first equation and got y equals 12/5. So then the answer to D and the answer to E are pretty much the same thing. The answer is the coordinate 2, 12/5. Again, you could have done this using substitution method by setting these two equal to each other, or you could have used your graphing calculators, have this be y1 and this be y2, and find where the two lines intersect each other. So past paper question 1 asks us about the line y equals 3x plus 4, and then some different questions about this. So part A just asked us for the slope, so we can read that right out of slope-intercept form. Our slope is 3. Part B asks us what the slope of a line perpendicular would be, so that would be flip it over and change the sign, so negative 1/3. Part C asks us the equation of the line perpendicular through the point 6, 7. So I use point slope form, y minus 7 equals negative 1/3 x minus 6. It does not ask for the form in any specific form, so you could have left it here. I knew it later on that it would help me to switch it into slope-intercept form, so I did. I solved for y and got y equals negative 1/3 x plus 9. But both of these would be correct answers. Part D wants us to find the intersection of those two lines. You could use your graphing calculator, y1, y2, and find where they intersect. I use substitution method. I set these two equal to each other and solve for x and got x to be 3/2 or 1.5, and I plugged that into the second equation and found y to be 8.5. So my coordinate is 1.5, 8.5. Past paper question 2 asks us about 3 points. A is 0, 4, B is 6, 0, and C is 8, 3, and then asks us some different questions about those 3 points. So part A asks us the slope of the line segment AB. It doesn't matter which order, whether you pick A to go first or B to go first. I picked A to go first, y minus x over y, y minus y over x minus x. Make sure you line up the correct coordinates. So I have 4 minus 0 over 0 minus 6, and you get 4 over negative 6, or negative 2/3. Part B asks us to find the midpoint of line segment AC. So that's taking the average of the x coordinate, 0 plus 8 over 2, and the average of the y coordinates, 4 plus 3 over 2, and you end up with 4, 3.5. Part C asks us to find the distance between A and C, so that's distance formula. So square root, again, it doesn't matter which order you do inside the parentheses. I did C minus A, so 8 minus 0 quantity squared plus 3 minus 4 quantity squared. So you end up with the square root of 8 squared plus quantity negative 1 squared, which is the square root of 64 plus 1, or the square root of 65. If you plug that in your calculator, you get 8.06. Part D wants us to find the equation of the line BM, where M is this midpoint that you found in Part B. So I found the slope, 3.5 minus 0 over 4 minus 6. So you get 3.5 over negative 2, which is 7/2 over negative 2, or negative 7/4. So that's your slope. And then I use point slope form using point B. So you get y minus 0 is equal to negative 7/4 over x times x minus 6. We wanted to put it in standard form, so I need to clear out this denominator, so I multiplied everything by 4. So you get full y is equal to negative 7 times the quantity x minus 6. And then I distribute this negative 7, you get 4y is equal to negative 7x plus 42. And then move everything over to one side, you get 7x plus 4y minus 42 is equal to 0. Also, if you had subtracted this 4y across, a correct answer would have been negative 7x minus 4y plus 42 is equal to 0. So all three of these could have changed signs and still be correct. Part E wants us to know if line segment AB is perpendicular to line segment BC. So we already found the slope of AB in Part A, that was negative 2/3. So we need to find the slope of BC. So again, doesn't matter which order you subtract as long as y's are on top and x's are on bottom and the pairs match up. I did point C minus point B, so 3 minus 0 over 8 minus 2. You end up with 3 over 2. So we have negative 2/3 and 3 over 2. Those are opposite reciprocals, so therefore the two line segments are perpendicular to each other. So this has been the review video for the Chapter 5 quiz. Hopefully this helped.